Welcome to the lecture number 10. Okay, in lecture number 9 we have seen the property number 5, that is division property. Now in this lecture we are going to study the property number 6, that is integral property. Integral property, the name of the property is integral property. Okay, so now what is this integral property? Let us see. So if Laplace transform of f of t is equal to f of s, then Laplace transform of integration from 0 to t, okay, into f of t dt is equal to 1 upon s into f of s, 1 upon f of s into 1 upon s into f of s. So this is the integral property. This is very simple property. Okay, that means if there is integration sign from 0 to t with the f of t, then we have what we have to do, just we have to find out the Laplace transform of this f of t, and just by using integral property what we have to do, we have to divide that f of s by s. This is the very simple property. Okay, now let us see some examples on this. So the example number 1. Okay, so the question is, find Laplace transform of, okay, find Laplace transform of integration from 0 to t into sin t into dt. Okay, so this is the example. That means here integration property and multiplication property are the combination. So now what to do and how to simplify this type of examples, let us see. So first of all, given Laplace transform of integration from 0 to t into sin t into dt. Okay, now comparing with integration from 0 to t, Laplace transform of integration from 0 to t f of t dt. What we get here? What is value of f of t here? So that is equal to t into sin t, isn't it? So f of t is equal to t into sin t. So first of all, if you have to find out the Laplace transform of this, then what we have to do? We have to first find Laplace transform of sin t, and after that we can take the by using multiplication property we can find the Laplace transform of this f of t. So first let us find Laplace transform of sin t first. Okay, so Laplace transform of sin t is equal to, we know that 1 upon s square plus 1. Okay, so now after that this is what f of s. So therefore by using multiplication property, what we can write by using multiplication property? So by using multiplication property we can write this as Laplace transform of t into sin t is equal to minus 1 into d upon ds of f of s, that is 1 upon s square plus 1. Okay, so now this can be written as that is equal to minus 1 as it is. Now derivative of this, so s square plus 1 as it is, derivative of 1 is 0, minus 1 as it is, derivative of s square is 2s, plus 1 derivative of plus 1 is 0, divided by s square plus 1 bracket square bracket close, isn't it? Now that is equal to, this can be written as now minus 1 into, now simplify this, s square, okay, so sorry, this will be definitely 0, this is 0, so here you will get minus 2s upon s square plus 1 bracket square. So what is this? This minus will get cancel, or minus of plus. After that so that is equal to minus plus, that is 2s upon s square plus 1 bracket square. Okay, so this is value of f of s, small f of s, right? So now by using integral property by using integral property, what we can write? Laplace transform of, okay, integration from 0 to t, integration from 0 to t into t sin t into dt is equal to, what we have to do? Just we have to write down 1 by s into f of s as it is, 2s upon s square plus 1 bracket square. So this s and this s get cancelled. What we get? 2 upon s square plus 1 bracket square. This is Laplace transform of integration from 0 to t, t sin t dt. Okay, so very simple, isn't it? Now let us take another example. So example number 2, find Laplace transform of integration from 0 to t e raised to minus t, okay, into sine of 3t divided by t into dt. So what is here? So here first shifting property, division property and integral property. So three properties are combined here, okay. Three properties can also be combined, okay. So now how to solve this? Simple. How to solve this? So given Laplace transform of e raised to minus t, integration from 0 to t first, e raised to minus t sine of 3t divided by t into dt, okay. So comparing with Laplace transform of integration from 0 to t into f of t into dt, isn't it? So if you compare this, what we get here? F of t is equal to what? E raised to minus t into sine of 3t upon t. So to solve this, okay, already we have seen such type of examples in the division property and multiplication property, okay. So now first of all, what we have to do? We have to solve the division property first, okay, and after that we have to use first shifting property. So now to solve division property first, okay, so solve by using division property first and then use first shifting property, isn't it? So now for that, now to use division property first, so what we have to do? So let us find Laplace transform of sin 3t first, okay. So therefore Laplace transform of sin 3t is equal to 3 upon s square plus 9, okay. So now so by using division property, what we get? So let us see. So by using division property, okay, Laplace transform of sin 3t upon t is equal to integration from s to infinity into f of s. So f of s is 3 upon s square plus 9 into ds. So now that is equal to what? This 3 can be taken outside. S to infinity 1 upon s square plus 3 square into ds. So by using formula 3 upon, then 1 upon a, that is 3, into tan inverse of s upon a, that is 3, limit from s to infinity. So this 3 get cancelled. What do we get? Tan inverse of infinity minus tan inverse of s upon 3. So this is pi by 2 minus tan inverse of s by 3. What is this? This is cot inverse of s by 3, okay. So this is now actually Laplace transform of sin 3t divided by t, okay. Now by using first shifting property, Laplace transform of e raised to, how much was given? E raised to minus 3t into sin 3t upon t, okay. So what we get? Cot inverse of s by 3 at s is equal to s plus 1, okay. So now if you put this value here, what we get? cot inverse of, in place of s we have to write down s plus 1, so s plus 1 upon 3. So this is your small f of s. Okay, and after that, by using which property? Now by using integral property, by using integral property, Laplace transform of integration from 0 to t e raised to minus t sin 3t upon t into dt is equal to what? Just 1 upon s into cot inverse of s plus 1 upon 3, and this is your final answer. Okay, is it simple? So now let us take another example, example number 3. Let us see example number 3. So find Laplace transform of e raised to minus t integration from 0 to t, okay, into e raised to minus t, okay, in bracket 1 minus cos t upon t bracket close into dt bracket close. Now this is little bit different. Okay, so let us see, let us first understand what this question is. So what is the meaning of this question? So e raised to minus t is at the outside of the integral as well as inside the integral. So how to simplify this? So what are the steps for this? So first of all, we have to find out the Laplace transform of this division property by using division property of this term. After that, we have to use first shifting. After that, we have to use integral, and after that, we have to use again first shifting. So what is the procedure or the steps? Look at this steps. So first step first. Okay. First, find Laplace transform of 1 minus cos t. Okay. First, find Laplace transform of 1 minus cos t. Step 2, use division property. Third, use first shifting property. Fourth, use integral property. And fifth, use first shifting property. Okay, so these are the different steps. I hope you understand this. Okay, so now let us solve this. Okay, so by using first step. Okay, so first let us use step number 1. So Laplace transform of 1 minus cos t is equal to what? Laplace transform of 1 minus Laplace transform of cos of t. Okay, so now that is equal to Laplace transform of 1 is 1 by s. Laplace transform of this will be s upon s square plus 1, isn't it? So by using step 2, अब स्टेप 2 में क्या करना है आपको? बाय यूजिंग डिवीजन प्रॉपर्टी. सो लाप्लास ट्रांसफॉर्म ऑफ 1 minus cos t upon t is equal to what we get? Integration from s to infinity 1 upon s minus s upon s square plus 1 into ds, isn't it? So now that is equal to, now here integration of this will be easily find out, but here if you see this, the derivative of s square is 2s, but here there is no 2. So what we have to do for this? So we have to divide, multiply and divide by 2. Remember this, okay? This is very important step. So what is integration of 1 by s? Log of s minus this 1 by 2 will be as it is, and the derivative of s square is 2s, so therefore log of this term s square plus 1. Okay, please concentrate here how I have solved this. Look at this again. What we have to do, we have to find the integration of s upon s square plus 1, but the derivative of s square is 2s. Here there was no 2, so what we have to do, what we have done here, multiplied by 2 and divided by 2. Okay, so what this 1 by 2 will be as it is, and log of this denominator, so that is equal to log of s minus, so first of all we have to take this 1 by 2 in the power, so log of s square plus 1. So when this 1 by 2 will be here, this is root, so this is nothing but root of s square plus 1 limit from s to infinity, that is equal to log a minus log b, so log of a upon b under root square plus 1 limit from s to infinity. Okay, so now if you put here upper limit minus lower limit, then what will we get? Infinity by infinity, so that is wrong. So what we have to do for that, take s common, that is log of s, numerator already there is s, so from this denominator, if you take s square common and again if you take it outside the root, then it will be only s. So what will we get inside? 1 plus 1 upon s square. Remember this. Okay. So now if you simplify this s and this s will get cancelled. Now put upper limit minus lower limit. So what we get here? If you put upper limit minus lower limit, what we get here? So that is equal to okay, what was that? Log of okay, log of 1 upon under root 1 plus a square upon infinity square bracket close minus log of 1 upon under root 1 plus a square upon s square bracket close, isn't it? Now that is equal to, now a square upon infinity square is 0, 1 plus 0 is 1, root 1 is 1, 1 by 1 is 1, so log 1 is 0, minus here log of, okay, bracket 1 upon under root, this will be a square plus a square, cross multiplication, a square plus a square upon a square, but this a square we can take at the numerator. So that is equal to what? If you change this minus sign, what we get here? Log of under root a square plus, whether it was here 1 or, okay, sorry, here it was 1, sorry, here it was 1, so this is not square, this is 1, only 1, okay, 1 upon a square, so this is 1, sorry, so a square plus 1 upon s, okay, so this is the answer of Laplace transform of 1 minus cos t upon t bracket close, that is equal to log of under root s square plus 1 upon s, okay. Or this also can be simplified as, if you write this like this, under root s square plus 1 upon, can we write this as under root s square? Can we write this? Yes, definitely we can write this. So this root and this root can be written in one bracket, and this root like this, s square plus 1 upon s square raised to 1 by 2, and finally we can write this 1 by 2 here, so log of s square plus 1 upon s square, here we can write this. Okay, so this is Laplace transform of this. Laplace transform of 1 minus cos t upon t. Now after that, by using first shifting property. So what is that? Laplace transform of e raised to minus t 1 minus cos t upon t bracket close is equal to 1 upon 2 log of s square plus 1 upon s square bracket close at s is equal to s plus 1. So put that value, what we get here? If you put this value, what we get here? If you put this value, okay, here what we get? That is equal to 1 by 2 log of s plus 1 bracket square plus 1 upon s plus 1 bracket square. Okay, now if you simplify this, 1 by 2 log of, here it will be s square plus 2s plus 1 that is 2 divided by s plus 1 bracket square bracket close, isn't it? Now, so this is Laplace transform of e raised to minus t into 1 minus cos t upon t. Okay, now after that, by using integral property, by using integral property, what we get? Laplace transform of integration from 0 to t into e raised to minus t 1 minus cos t upon t into dt is equal to, just what we have to do, we have to multiply it by s. So here 1 by 2s log of s square plus 2s plus 2 upon s plus 1 bracket square bracket close. Okay, so again finally we can write this as okay, but again by using, lastly by using first shifting property, and this is the last step. Okay, so Laplace transform of e raised to minus t integration from 0 to t e raised to minus t 1 minus cos t upon t into dt. Okay, so that is equal to just put the value, so 1 upon 2s into log of s square plus 2s plus 2 upon s plus 1 bracket square bracket close. Okay, that is at s is equal to s plus 1. Now put the value, what we get here, 1 upon 2 into s plus 1 log of s plus 1 bracket square plus 2 into s plus 1 plus 2 divided by s plus 1 plus 1 bracket square. So now simplify this finally, 1 upon 2 into s plus 1, okay, log of s square plus 2s plus 1 plus 2s plus 2 plus 2 divided by s plus 1 plus 1 2 square. Finally 1 upon 2 into s plus 1, okay, bracket close, log of bracket s square plus this 2s plus 2s 4s plus 2 plus 2 4 plus 1 5 upon s plus 2 bracket square bracket close. This is your final answer. Okay, so in this way you have to solve this property. Okay, I hope you understand everything. Now let us take some examples for homework. So example number 4, okay, find Laplace transform of sine hyperbolic 2t into integration from 0 to t into t cos 2t. Okay, this is example 4, and example number 5, find Laplace transform of e raised to minus 2t integration from 0 to t e raised to minus t into cos t, t into cos t into dt. Okay, so these examples are for homework. Okay, so thank you very much. In next lecture we will see the next property. Thank you.